Picking up where we left off, we have number 3 here, and we have 25 minus 10 and 2/9. If you notice here, there's no fraction with this 25. Now, what I would suggest that we do is this here, just to make it a lot easier on ourselves. Let's keep our fraction on the bottom the same, which is 10 and 2/9. Now, what we're going to do is we're going to borrow 1 from this 25 and make it 24. So that 25 would become 24. And the one that we borrow, we would do this. Always look at your denominator in the other fraction. Whatever that denominator is, your numerator and denominator would be the one that you borrowed. So now the one we borrowed, we'll borrow 1 from this 25, that gave us 24. And the one that we borrowed as a fraction will have this same denominator. So it'd be the numerator and denominator. So 24 and 9/9 is the same as 25. And the reason why we use that same denominator is so we can easily subtract. 9/9 minus 2/9 is 7/9. 24 minus 10 is 14. So it's 14 and 7/9. Now we look here at number 4. We have a negative 5 and 6/7 plus 2 and 13 over 14. Let's disregard the negative sign for now. We know we're going to subtract, but we'll figure out what we do at the end of the problem. So we'll just say 5, 6 minus 2 and 13 over 14. Now, let's find the common denominator of 7 and 14. 7 is already prime. 14 breaks down to 2 and 7. So our LCD is 2 times 7. So our LCD is 14. So our LCD is 14. So we will write this again. This would be 5. Our denominator would be 14. Minus 2. Our denominator would be 14. So we know 14 divided by 14 is 1. So we'll multiply the numerator and denominator by 1. And that will give us 13. 14 divided by 7 is 2. So we'll multiply our numerator and denominator by 2. And that will give us 12. Now if you notice here, this fraction on the bottom is larger than the fraction at the top. So you know now we have to borrow 1 from this 5. We borrow 1 from this 5, this becomes a 4. Now, this becomes 4. Our denominator here would still be 14. And our numerator, we'll take 14 plus 12, which is 26, equals minus 2, 13 over 14. Now we subtract 26 over 14 minus 13 over 14 will give us 13 over 14. 4 minus 2 is 2. So we add 2 13 over 14. Now we look here. Which one of these numbers without the sign is the largest? We know 5 and 6/7 is. And since it has the negative sign, your final answer would be negative. So it would be a negative 2 and 13 over 14. Now we go to example set C. It says 2 rainbow trout weigh 2.5 pounds and 3 2/3 pounds. What is the total weight of the 2 trout? Now when they ask you for total weight, they're asking you to add. So we would take 2.5 plus 3 2/3. Now we need to find our common denominator. Now we could go to the side here. 2 is prime and also 3 is prime. So our LCD is 2 times 3. So our LCD is 6. So our denominators here would be 6. So we would say 6 divided by 3 is 2. So we'll multiply this numerator and denominator by 2. 3 times 2 is 6 and 2 times 2 is 4. Now we say 6 divided by 2 is 3. So we multiply our numerator and denominator by 3. 2 times 3 is 6, and 1 times 3 is 3. So now we add them. 3 6 plus 4 6 is 7 6, and 2 plus 3 is 5. Now there's a problem here. This is an improper fraction. So we need to go off to the side and ask ourselves, 6 goes into 7 once, and we have a remainder of 1. So that 1 that's here, we will add it to this 5. So this will give us 6. Our denominator still will remain 6, but now our numerator is the remainder. So our final answer would be 6 1/6 pound, because we cannot forget the units of measure. So again, we find out what this mixed number is. We'll take 6 and a 7 goes once. We have a remainder of 1. Whatever number is in front of your remainder adds to this whole number here. So if that was a 2, then this would be 7 1/6. So then we add 1 to this 5. This is 6. Our denominator stays 6, and our numerator is our remainder. And that's it for this problem. Now we start section 310. We have order, exponents, and other operations. Section A, we're comparing fractions. We use inequality symbols less than or greater than to write the order of numbers. We will be using these inequality symbols to compare fractions. Inequality symbols. This means less than, this means greater than. Comparing fractions. Step 1, write the fractions as like fractions. Step 2, the fractions with the greatest numerator, the greater numerator is the greatest fraction. Right here shows what we were just discussing. They have the same denominator, and we look at the numerators. This 2 is larger than this 1, so we know the inequality points to the smaller number. Same thing here, same denominator. This numerator is larger than this numerator, so this inequality points to the smaller number. So this is 2/3 is greater than 1/3, 5/6 is less than 7/6. Now we could use that method, but there's actually an easier method that I have shown you all in an earlier lesson. Remember when we were trying to find out if fractions were equal to each other? We could use that same process with that cross products. We could take 8 times 11, and then we would take 9 times 10. Remember that? We take the top of the first times the bottom of the second. That will give you this value. The bottom of the first times the top of the second will give you this value. So this is 88 and this is 90. Which one is greater? We know 90 is greater. So that means that 10 over 11 is greater than 8 over 9. So remember, and you must do it in that order. Top to bottom goes first, bottom to top goes second. So we could do that with number 2. We have 3 times 9, and then we will have 5 times 2. 3 times 9 is 27, and 5 times 2 is 10. We know that 27 is greater than 10, so we'll put our greater than symbol here. Now we could do the same thing here, 1 times 3, and then 5 times 2. So this is 3 and this is 10, and we know 10 is greater than 3, so 2/3 is greater than 1/5. Now we do this here, 11 times 8, and then we'll do 12 times 7. 11 times 8 is 88, 12 times 7 is 84. And we know 88 is greater than 84, so 11/12 is the greatest. Now we go to example set B. It says evaluate each expression. We're dealing with fractions being raised to an exponent. Now, because this whole fraction is in a parenthesis and the exponent is on the outside of the parenthesis, that means that this whole fraction is taken to the second power. So this is the same as this here, because it's to the second power. Now we go top times top, 1 times 1 is 1, bottom times bottom, or denominator times denominator, 5 times 5 is 25. So your final answer here is 1 over 25. Now we look here at number 2. We have this first fraction in parentheses squared, so we have 1/4 times 1/4. And then we have the second parenthesis taken to the third power, which is 2/3 times 2/3 times 2/3. Now, because this is such a long fraction, let's do like we did before when we were simplifying with multiplication. You have 1 times 1, which is 1, and we have other numbers besides 1. So we'll write those numbers. 2 is prime, 2 is prime, is 2 is prime. So we'll write down all of the prime number 2's. Now this 4, the prime factorization of 4 is 2 and 2. The prime factorization of 4 is 2 and 2. And all of these 3's are prime. Now we simplify out what they have in common. They have 3 sets of 2's in common. So your numerator would be 1. And your denominator would be 2 times 3 is 6, times 3 is 18, times 3 is 54. So your final answer here is 1 over 54. Now, a quick little review of the operations on fractions. We know that with multiplication, we multiply straight across and we do the prime factorization, and then we simplify as needed. With division, we know we keep the first value the same, change division to multiplication, and take the reciprocal of the second value, which we did here, and then we do the same procedure we would do with multiplication. Now, with addition or subtraction, you have to find the common denominator and then proceed to do whether you add or subtract your numerators. Now, we've covered all that before. That was a very brief refresher. Now, we go down here to exercise set C. Now, we had division. Okay, first thing, we would keep this first fraction the same. Division would become multiplication, and we'd take the reciprocal of the second fraction. Now we take the prime factorization of all of these factors. 3 is prime, 11 is prime. 7 is prime, but 10 breaks down to 2 and 5. We see here we have nothing in common. So 3 times 11 is 33, and 7 times 2 is 14, times 5 is 70. So that is your answer, 33 over 70. Now we go here to number 2. Now this is addition. We need a common denominator, so we'll go off to the side. We have 15 and 5. 15 breaks down to 3 times 5, and 5 we already know is prime. So the LCD, based upon what you learned before, is 3 times 5. So your LCD is actually 15. Now for some reason this screen had jumped a little bit, but you could rewind and see what this problem looks like without it jumping like this here. But going here to number 2, it looks as though that it's repeating here, but we see our common denominator is 15. So we'll do 4 over 15 plus 2 over 5. Our common denominator is 15. So we say 15 divided by 15 is 1. So we multiply our numerator and denominator by 1. And that will give us 4 over 15. 15 divided by 5 is 3. We multiply our numerator and denominator by 3. 2 times 3 is 6, and 5 times 3 is 15. So now we add them together. 4 plus 6 is 10 over 15. Now, we could take the prime factorization of 10, which is 2 and 5. And the prime factorization of 15 is 3 and 5. These 5 simplify out, and you're left with 2/3. And that is your final answer. Now, we go down here to number 3. We have multiplication. Now, again, we just multiply straight across, taking the prime factorization. 2 is prime. 9 breaks down to 3 and 3. Here 3 is prime. 10 breaks down to 2 and 5. Now, these 3's simplify out. These 2 simplify out, and you're left with 3/5. Now for number 4, we have to find the common denominator of 12 and 5. So we go off to the side. 12 breaks down to 2 and 6, and 6 breaks down to 2 and 3. So the prime factorization of 12 is 2, 2, and 3, and 5 is already prime. So our LCD here is actually all of these numbers because none of them match up. So 2 times 2 is 4, times 3 is 12, times 5 is 60. So our common denominator here is 60. So we'll write 11/12 minus 2/5. Common denominator is 60. 60 divided by 12 is 5. So we multiply our numerator and denominator by 5. 60 divided by 5 is 12. So we multiply our numerator and denominator by 12. 5 times 11 is 55, and 2 times 12 is 24. So now we add them. We subtract them. 55 minus 24 will give us, what's that, 29. So we had 29 over 60. And that is our final, actually no, I'm sorry, that's supposed to be 31 over 60. It's supposed to be 31 over 60. So our final answer here is 31 over 60. And that is it for this problem.